This data shows two parallel paths to the same destination, whether participants follow a strict intermittent fasting schedule or a standard caloric deficit. Their weight loss trajectories remain nearly identical. The clinical consensus is clear. Restricting when you eat does not inherently burn more fat than simply restricting how much you eat. The biological interest in fasting begins at the 12-hour mark. This is the metabolic switch, the moment the body exhausts its preferred fuel, glucose, and begins burning stored fat to keep the lights on. Crossing this threshold triggers a systemic response. Insulin levels drop, the brain increases production of growth-supportive proteins, and the body initiates a cellular maintenance routine that typically remains dormant during constant feeding. However, these benefits are not a universal guarantee. Recent data suggests that prolonged fasting windows can disrupt female reproductive hormones, and extreme regimens have begun to raise red flags regarding long-term cardiovascular health. Because fasting fails to outperform standard dieting for weight loss, the scientific case for the practice relies on its impact beneath the surface. The value of a timed fast is found in its ability to initiate cellular repair work that weight loss alone cannot trigger. In a state of constant feeding, our cells are flooded with energy. This baseline forces the body to rely exclusively on quick-burning glucose for fuel, keeping the system in a perpetual state of growth rather than maintenance. This timeline tracks the transition to survival mode. At the 12-hour mark, once glucose reserves are fully depleted, the liver begins converting fatty acids into ketones, an alternative high-efficiency fuel for the body and brain. The presence of ketones signals the cell to begin autophagy, literally self-eating. This is a scavenging mechanism where cells consume, break down, and recycle their own damaged proteins and dysfunctional internal components. We evolved to perform a version of this cleanup every night. Sleep activates the glymphatic system, a biological waste clearance pathway that washes metabolic debris out of the brain while we are in a fasted state. By intentionally depleting our glucose stores, we manually override the body's default growth settings, activating an ancient repair sequence designed to maintain the system during periods of scarcity. To see if these mechanisms survive real-world application, researchers at Rutgers University conducted a clinical trial comparing time-restricted eating protocols directly against conventional daily dieting. The study found that fasting did not possess a unique metabolic advantage for fat loss. Any weight lost by the fasting group was a byproduct of an incidental caloric deficit. They simply had fewer opportunities to eat. The research also highlights how fasting affects women differently. Kisspeptin neurons in the brain, which regulate reproductive cycles and appetite, are particularly sensitive to the stress of sudden energy restriction. When these neurons detect a survival threat from prolonged fasting, they can trigger a hormonal cascade that increases cortisol levels and slows thyroid function. Further scrutiny from the American Heart Association has raised questions about the popular 16-8 method. Their findings suggest that extremely narrow eating windows might be linked to higher cardiovascular risks in certain populations. Treating intermittent fasting as a one-size-fits-all diet hack ignores the individualized stress it places on the cardiovascular and endocrine systems. Fasting is a deep historical baseline, utilized by thinkers like Socrates long before it was a modern trend. Our evolutionary hardware is built to expect these periods of quiet. For most people, a 12-hour window, such as 8 p.m. to 8 a.m., represents a sustainable biological alignment. It provides the system enough time to reset without forcing it into a state of metabolic emergency. This 12-hour fast is sufficient to trigger the metabolic switch and initiate autophagy, but it stops short of the extended restriction that triggers significant cortisol spikes and hormonal dysregulation. This graph illustrates hormetic stress. Just as lifting weights creates micro-tears to prompt muscle growth, brief periods without food create a mild metabolic tension. This tension forces the cell to activate internal protection systems and repair mechanisms. Biology was designed to survive scarcity, but we now inhabit an environment of endless calories. Intermittent fasting is not about starving. It is about allowing the body's internal repair crew the time it needs to wake up and do its job.